Hey, Course 3. Let's try Lesson 65 again. I guess I recorded without my microphone plugged in. Mistakes happen. We're going to move on. Try this again. Today's lesson involves using triangles to solve word problems that don't seem at first glance to have anything to do with triangles. Mara Cruz wants to know the height of a flagpole. Not a triangle, a flagpole. This one. Okay? So she takes a meter stick on end and finds its shadow is 120 centimeters. A meter stick is in centimeter, 100 centimeters. She measures the shadow of the flagpole. That's 30 meters. How tall is the flagpole? She's using indirect measure, or not measuring, not holding the ruler up to what she's trying to measure, but instead doing it indirectly because it's hard to measure a flagpole. Because, and this, what this really does is, if you haven't figured it out yet, this basically is creating a triangle if we drew an imaginary line that forms a hypotenuse. So we have the flagpole triangle and the meter stick triangle, and they form what's called similar triangles because they share sun at the same angle, right? It's coming out at the same angle, which means that the hypotenuse is the same angle and creates a proportion. Remember, similar triangles means measures might not be the same, but the proportions are there because it's basically the same triangle, but either zoomed in or zoomed out, either stretched out to be bigger or shrunk down to be smaller. So this has the same proportions as this, it's just shrunk down. Meter stick is 100 centimeters. Shadow is 120. So let's just set up a ratio. And that has the same proportion, same ratio as the flagpole to its shadow. Okay, and how do we solve proportions? There's a couple ways. We could say, well, 120 divided by 40, no, 4 is 30. Therefore, 100 divided by 4 is 25, and that is the answer. We can also cross multiply, right, and find that 3,000 is 120p. Divide both sides by that 120, you should also get 25. The flagpole is 25 meters high. You could convert this into meters and get the same thing. It doesn't actually change the answer. So 25 meters there. Now this one's a little more complicated, but it does involve two similar triangles. Josh wants to measure the distance from this end of the lake to this end from the center, and that's a hard measure unless you're going to walk through the lake. So he has an idea. He's going to stay where he is, okay? Mark his position with a stone, walk out 10 yards, and put a stake in the ground. Okay, so this is 10 right here. Ties a string, goes perpendicular up here, actually no, first he walks back to here, goes towards P2, and makes a stake, then ties a string to the two of them. Josh knew that the distance from his starting position to P1 is 45, so that means this whole length is 45. Somehow he just knew that. Therefore, what is this whole length? No, not this whole length. This whole length. This height. He also knows that this is 8. We don't need this. So what he's created is two similar triangles. The smaller one, which is 10 towards P1, and the string is 8, it says. And then on top of that, right, like this, it's a similar triangle because they share this vantage point, this Josh Stone vantage point, this bigger triangle which also has 90-degree angles, which the top angle is the same as this top angle. The angles all measure the same. It's similar. We want to know this, and we know that this is 45. Josh to P1 is 45. So how do we set up our proportion? You could do it a couple of ways. Let's try 8 to 10 is x to 45. Same proportion. We could reduce this down too. We could divide both by 2 and use 4/5. I think that's fine. A little easier than to use 5x is 4 times 45. Divide by 5 means x equals 4 times 9. X is 36. You could have also said if 5 times 9 is 45, 4 times 9, because these are all nice and even, is 36. "36 yards." So they, again, used indirect measure, created two triangles that are similar because they share that vantage point, whether it's the sun or Josh's stone. We can use proportions then to solve. Using similar triangles to solve word problems. Why don't you show me that with letter B?